The bottom of our world is thirsty. Deep beneath the Pacific, a colossal crack in the planet's crust is swallowing the ocean, and the amount it's drinking defies belief. You're looking at the Mariana Trench, 11 kilometers straight down, a place of absolute darkness and crushing pressure. Imagine the weight of a jumbo jet balanced on your fingertip. That is the pressure here. For decades, we saw this place as a simple geological feature, a line on a map where one tectonic plate, the massive Pacific Plate, slides under another. This process is called subduction. It's a grinding collision that builds mountains and fuels volcanoes. That was the clean, simple story we were told. But the truth is far messier and much more alarming. Here's the part nobody talks about. In 2018, a team from Washington University decided to listen. They dropped 19 advanced seismographs to the bottom of the trench. What they heard was not silence. It was the sound of a world being torn apart. As the Pacific Plate bends downwards, it doesn't just slide. It cracks. It shatters, creating thousands of deep fissures that run for kilometers into the rock. And into these cracks, the ocean pours. Seawater floods the broken crust, chemically bonding with the minerals, becoming trapped inside the rock itself. This waterlogged rock is then dragged down, deep into the Earth's mantle, hundreds of kilometers below the surface. It is a one-way ticket. The scientists calculated the volume. The trench is pulling down over 3 billion teragrams of water every million years. That is more than 3 times the amount previously estimated. Think about what that means. The planet itself is drinking its own oceans on a scale we never imagined. So here's the paradox. A process is actively removing enormous volumes of water from the global ocean. Yet our sea levels are not falling. They are rising, frighteningly fast. If the Earth is swallowing the sea in one place, where is all this extra water coming from? And what happens when a system this powerful starts to change? The crack we see on the seafloor is not an end. It is a beginning. You are looking at the entry point of a planetary machine, a vast geological conveyor belt, and it is pulling the ocean floor down into the Earth itself. The Pacific Plate, an immense slab of oceanic crust, is being forced to bow and scrape under the neighboring Mariana Plate. It's a process called subduction. The movement is almost imperceptible. The plate descends at about 3 centimeters per year, roughly the same speed your fingernails grow. But do not mistake this for gentleness. The forces at work here are beyond comprehension. The pressure builds to over 160,000 pounds per square inch. Imagine the weight of 3 jumbo jets stacked on a single postage stamp. That is the pressure squeezing this rock. As the plate bends and breaks on this downward journey, it opens up fissures and faults. Seawater, cold and dense, floods into these new wounds. And here is where it gets interesting. The water does not just fill the cracks, it chemically attacks the rock. It triggers a transformation called serpentinization, turning hard mantle rock into a soft, greenish mineral filled with water. The rock becomes a sponge on a one-way trip into the planet's interior. For decades, geologists knew this was happening. They assumed some water was being ferried into the mantle, a modest amount. But they were wrong. Terribly wrong. In 2018, a team at Washington University in St. Louis, led by researcher Chen Kai, placed a network of seismographs around the Mariana Trench. They weren't just looking, they were listening to the echoes of earthquakes as they passed through the subducting plate. As the speed of these seismic waves told them a story, It gave them a picture of the rock's structure, its density, and just how much water it was holding. The results were stunning. The models suggested the plate was dragging down 3, even 4 times more water than anyone had ever predicted. We're talking about billions of kilograms of water every million years, an amount of water so vast it defies easy comparison. Think about that for a moment. The Earth's deepest trench is not just a scar. It is a drain, a planetary drain, swallowing the ocean and pulling it deep into the mantle. This water, now trapped inside the crystal structure of minerals, begins its long descent. As the plate sinks deeper, the temperature and pressure continue to rise. At around 100 kilometers down, the heat becomes too much. The sponge is squeezed. And the water is forced out of the minerals, but it is not water anymore. It is a supercritical fluid, a strange state between liquid and gas. And this fluid is the lifeblood of volcanoes. It seeps into the mantle above the descending plate, lowering its melting point. Solid rock begins to melt, forming magma. This magma, less dense than the rock around it, rises. It punches through the crust above, creating the entire volcanic chain of the Mariana Islands. Every eruption you see is the ghost of the ocean returning to the surface. It's a perfect system, you might think, a beautiful cycle. Water goes down, volcanoes spit it back out. Balance is maintained. But what if it isn't a perfect system? What if the math doesn't add up? Scientists have measured the water vapor erupting from all the world's volcanoes. They have a good estimate of how much water the planet exhales, and it does not match the colossal amount of water being swallowed at the Mariana Trench and other subduction zones. Not even close. If the Earth has been drinking this much more water than it breathes out for hundreds of millions of years, where is it all going? And what happens when the planet's interior has finally had too much to drink? The problem isn't the crack itself, it's what's pouring into it. An impossible amount of water is disappearing from the surface of the Earth. So the real question, the one that keeps geologists awake at night, is simple. Where is it all going? The answer takes you on a journey to a place more alien than the moon. Down, into the planet's engine room, the Earth's mantle. You picture the mantle as a sea of liquid fire. It's not. It's mostly solid rock, but under such colossal pressure that it flows like hot asphalt over millions of years. And that Pacific plate, the one diving into the trench? It's carrying its watery cargo right into this furnace. Think of the plate not as a smooth surface, but as a shattered mirror. The bending force as it plunges downward creates thousands of faults. Cracks. These cracks act like superhighways, allowing seawater to travel deep into the rock. The water then reacts with a mineral called olivine. The result is a new kind of rock, serpentinite. And here's the key. Serpentinite is a geological sponge. It can hold up to 15% of its weight in water, locked directly into its crystal structure. This isn't just a wet rock. The water has become part of the rock itself. So you have this cold, waterlogged slab of ocean floor, and it's being shoved into a kiln that reaches 1,100 degrees Celsius. What do you think happens? The pressure cooker turns on. The immense heat and pressure literally squeeze the water back out of the serpentinite. It's a process called dewatering. This freed water, now superheated and highly corrosive, has to go somewhere. And this brings us to the accepted textbook explanation. The story they tell you in Geology 101. This water seeps into the mantle rock above the descending plate. Water, as you know, lowers the melting point of almost anything. Add water to hot mantle rock, and it melts. This creates magma. This magma, being less dense than the surrounding rock, rises. It forces its way to the surface, and it erupts. This process created the Mariana Islands, a perfect volcanic arc tracing the line of the trench. It's a neat cycle. Water goes down, rock melts, volcanoes erupt, the water is recycled back into the atmosphere. Case closed. It makes perfect sense. Except for one detail, a very big detail. The numbers are wrong. A 2018 study led by researcher Chen Kai used a network of seismographs to listen to the Earth's deep rumblings. They analyzed how seismic waves down as they pass through the subducting plate, and their findings were staggering. The trench is swallowing water at a rate 3 to 4 times greater than anyone had ever calculated. 3 to 4 times more. Think about what that means. The volcanoes of the Mariana Islands. They can only account for a fraction of that water being returned to the surface. A small fraction. So if all that water isn't coming back up, where is it? This is the part nobody likes to talk about. The neat, tidy cycle is broken. We have an accounting error on a planetary scale. An entire ocean's worth of water over geological time is being pumped into the deep earth with no known exit. It's not being recycled. It's being stored. We are actively changing the composition of the deep mantle, and we are injecting the planet's fiery engine with its polar opposite, and we have no idea what the long-term consequences are. Perhaps this hidden water lubricates the fault lines, setting the stage for earthquakes more powerful than we can imagine. Or maybe it's altering the chemistry of the mantle itself, a poisoning from within. The dark irony is this. For decades we've stared at the skies, worried about asteroids and solar flares. We've obsessed over the rising oceans on the surface. But we never thought to look down. The greatest unknown isn't out there in space. It's right under your feet. A missing ocean hiding inside the earth, quietly pressure. For a moment, forget the impossible pressures and the alien life. Forget the geology. Instead, feel the air on your skin. It's warm, humid, thick with the smell of salt and tropical flowers. You are standing on Guam, the largest of the Mariana Islands. People live here. Generations of families call this paradise home. Their home sits directly on the lid of a planetary pressure cooker. The Chamorro people, the indigenous inhabitants, have been here for 4,000 years. Their culture is woven from the sea and the volcanic soil beneath their feet. They have always known the ocean gives and the ocean can take away. But they have never faced a threat on this scale. Here is the part nobody talks about. This isn't some abstract geological event in a remote abyss. This is a story about people. It's about the 170,000 American citizens living in Guam and thousands more across the Mariana Islands. Their homes, their schools, their entire existence are perched on the edge of the subduction zone. The ground shudders. It happens often. A low rumble you feel deep in your chest. A coffee cup rattles on a shelf. Then it stops. Just a tremor. For now. In the schools, children don't just have fire drills, they have tsunami drills. They are taught from the age of 5 to look for the signs. An earthquake that lasts for more than 20 seconds. A sudden, unnatural draining of the sea from the shore. And then they practice running. Uphill, as fast as their small legs can carry them. Think about what that means. To grow up knowing the beautiful ocean that feeds your family could, in minutes, become a wall of water moving at 800 kilometers per hour. The 2011 Tohoku earthquake in Japan was a subduction zone event. It unleashed a tsunami that traveled 10 kilometers inland. It was a magnitude 9.1 event, releasing energy equivalent to over 600 million atomic bombs. The Mariana Trench is capable of exactly the same. Dr. Douglas Wiens, a seismologist at Washington University, has placed seismometers on the ocean floor here. His data reveals a terrifying silence. The two tectonic plates are not smoothly sliding. They are locked, stuck. For decades, the Pacific Plate has been forcing itself under the Mariana Plate, bending it downwards like a diving board. Every year, the pressure builds. The water being dragged down into the mantle acts like a lubricant, but it also increases the stress in other areas, making the eventual snap even more violent. It is not a question of if. It is a question of when and how big. We look at the GPS data showing the strain. We read the seismographs that measure the deep, silent groans of the earth. But then you look at a fisherman mending his nets on a beach in Saipan, unaware that he is living on the edge of the most powerful geological engine on the planet. The science can predict the force, but it can never predict the human cost. And the final terrifying question isn't if the pressure will be released, but what happens to them when it is. So, the abyss is cracking open. You've seen the scars running for kilometers along the seafloor. You've heard the science. But you might be asking the wrong question. The question isn't why the trench is breaking. The real question is, what does it mean that our planet is still alive? Every year, the Pacific Plate grinds its way under the Philippine Plate. It moves about 10 centimeters. That is the same speed your fingernails grow. It seems like nothing. A geological crawl. But over millions of years, that relentless pressure builds mountains, and it shatters the oldest, coldest parts of the ocean floor. This isn't an accident. It's a funeral. The Pacific Ocean is dying, and the Mariana Trench is its graveyard. Every drop of water pulled down into the mantle. Every fracture in the crust is part of a cycle so vast it's difficult to comprehend. The Atlantic Ocean is widening. One day it will become the world's dominant ocean. Continents will drift, collide, and merge once more, forming a new Pangaea hundreds of millions of years from now. Here is the part that nobody talks about. The news might show you a headline about a catastrophic crack. They sell fear. But the truth is far more astonishing. This process, this violent motion recycling, is the reason you are here. Without plate tectonics, Earth would be a barren water world, or a dead rock like Mars. The volcanoes fueled by this subduction gave us our atmosphere. The shifting continents created diverse climates where life could flourish in countless forms. The groans from the deep are not death rattles. They are a heartbeat. The cracking of the crust is the sound of a planet breathing. It is a reminder that the ground beneath your feet is not static. It is flowing. It is moving. You are living on the thin skin of a restless, dynamic world. We measure our lives in days and years. We build cities designed to last for centuries. But the earth measures its life in eons. It builds and destroys on a schedule we can never truly grasp. And so, the real fracture isn't the one 11,000 meters below the waves. It's the one between our perception of time and the planet's. Knowing this, how do you choose to live on a world that is forever unfinished?